can guess what subject we are going to be about. Could you find out anything? Any guess what subject it is going to be? What do you see over there? Again, the simplest thing. What do you see over there? Kind of speaker. What is that? What is that? Let's have a practice session. It is a virtual assistant called Amazon's Alexa. Okay? So what is the use of it? So you are all familiar with all those things what has been displayed. What is the use of it? When you ask Alexa to respond something, what is the time now, what is the weather now, what is the date, or many information. So if you ask your Alexa to play a song, or you are asking any information, it will be able to respond to you. Rather than you are asking somebody else or searching the computer, you can just ask your Alexa, it will be able to give you response. Right? Beyond that, it cannot do anything. If you ask your Alexa to move out of the place or do something else, or dance for your music, something like that, it will not be able to do. It will be able to do only whatever you ask, it will be able to answer. What do you see over there? Kind of map symbol, Google Map, right? So everybody, we are all using the Google Map. It is powered, AI powered application. So everywhere you have a smartwatch, you have ChatGPT. So nowadays I can promise you, without this ChatGPT and without this Google Map, we are not living at all. Right? So frequently we are using all these things. So all are AI powered applications. So what you need to understand here is AI has created a greater impact on our day-to-day life. That is the reason we need to learn about artificial intelligence. Now, what is artificial intelligence? Artificial, cut the term into two, artificial and intelligence. Artificial means something, it is not coming naturally, we are going to create something. Intelligence is thinking part. Human is having naturally a thinking part which will be influenced or induced to the computer, so that computer will behave like a human, think like a human, act like a human, and even it will be able to make some decisions and it will give some recommendations to you also. Okay, so you are going with your friend to a shop and you are purchasing something. You will be asking your friend, what else I can buy? Okay, then your friend will be helping you. The same job will be done by your recommendation system of your various online shopping. Correct? Amazon, when you purchase something, it will tell you this thing also can be bought. Some people have these items not together, so it will tempt you to even to buy those items. So it gives you some recommendation. So it is taking some, it is learning of your shopping behavior. Based on that, it is giving you some recommendation. Okay, so on various ways, computer thinks on its own and it will be giving you a decision. It will be able to give you some ways to live your life. Yeah, so I can say that from the introduction, AI is everywhere. AI is everywhere, but we know only few domains where AI is there. But research is going on everywhere to make use of the artificial intelligence. So already process is going on. Gaming. Various AI powered games. Can anybody tell me? Have you ever played the game which is being powered by AI? Any game? Online chess is there, right? So you will be one player and your machine will be another player. So virtually you will be playing with another players. Like so many games are available currently itself. So gaming is the entertainment purpose of your AI, astronomy, healthcare, transportation. So you all are aware of that autonomous car is available, and for the traffic control AI applications are used. Okay. So agriculture, now to improvise the agricultural system, AI is in use. In our country, only in few places it is used. In abroad, already in the existing one only. Education system, e-commerce, entertainment, robotics, automotive, social media. So this is very familiar to you. Content creation or making some you're capturing a photo through your mobile phone, and then what the Google photo does. Sometimes it will create a memory and show you on the same day you were there, or this is the collective. So it is able to extract the similar things and it is able to create you an album or create a memory for you. Okay, so that has been covered by AI. So AI is there everywhere. So with this, let us move on to a formal definition of artificial intelligence. So artificial intelligence is a branch of computer science. Okay, it is a part of computer science. What exactly we are using? We are creating an intelligent machine. So earlier also we were using machine, but whatever you program, it will respond. When you type a program to find biggest among 3 numbers, it will be able to find biggest among 3 numbers. Whatever the coding you do, accordingly it was responding. But now I don't want to give any instruction. I should create a machine. As and when the input is given, it should give me the reply. Okay, so my program may be biggest among 3 numbers, or it may be of any other problem. Irrespective of my problem, my system should be able to respond me. So if it is intelligent, if we are a human, according to the situation we are able to behave. Right? According to the situation, we are able to behave. We are able to think. We are able to face any problem. When you find any problem, you find a solution for that, because we are having a thinking part. But now we are inducing a thinking part to the computer, so that we want to make the computer as an intelligent machine. So intelligent machine in a sense, it should exactly behave like a human. Okay, whatever I am doing, my machine should supposed to do. See, when a person comes, I am able to recognize who is that. Okay, sometimes back I would have met that person. The moment I look at him and say, he is so and so person only, she is so and so only. Okay, the same thing my machine should be able to do. I am given my face as a login when I enter into our college. Okay, so the moment it looks at me, okay, so it will recognize that yes, she is the person. Suppose some stranger is coming over there, if they are showing their face to the machine, it will not detect. It will not detect, because I have programmed, I have modeled my machine in such a way that it will be able to recognize my face and my attendance will be marked as present. For the attendance monitoring, that system I am using. Face recognition, face detection. Your Google Photos, how it is detecting the photo. So similar photos, all it is collecting and creating a memory. And if you just give one photo, I want the photos of all of that particular person, it will be able to give collective of that particular person. How it is making a comparison. Or in the whole image of a human, I want only a face alone, or I want to differentiate two different images. When you consider autonomous car, what do you mean by autonomous car? Autonomous car, driverless car. Okay, without a driver, a car can move. So when it travels on the road, it may find a lot of vehicles over there. So it has to maintain the distance. So it will see the distance. Accordingly, it will control its system. Okay, whenever it finds some obstacle, it has to put the brakes. So all these things are trained to the self-driving car. Okay, when it is detecting the objects in front of that, if it is a pedestrian, accordingly it has to leave a space. If it is another car of that size itself, accordingly it has to do some changes in its system. So it must know to detect the images. Okay, so that is possible with artificial intelligence system. What man is doing when a driver is there, human driver is there, we see whoever is crossing the road or whoever is passing the road, accordingly we will control our car. The same process needs to be done by the computer. Provided that it is having the power of thinking like a human, behaving like a human, and taking a decision like a human. Now I should apply brake. Now I can move. When I see a red light in the traffic signal, I have to put a brake. The decision is made by the computer like a human. That is the intention behind going for artificial intelligence. So now please go through the definition. It is a branch of computer science by which we can create intelligent machine which behave like human intensive task can be done. That is learning, reasoning, solving problems, and language understanding. Consider your Alexa itself. So with various accents you can talk to your Alexa. Okay, but still it will respond. It will respond because it will be able to understand my language. The natural language will be understood by my system and it is able to respond. Okay, I may ask Alexa play a song. Somebody may ask Alexa play a song, the variation. Okay, the modulation or the way I instruct my system may vary, but still my system should be able to understand my language. Accordingly, it should respond. Okay, so because we are able to do, right? We are able to do. I am able to communicate with the American or Canadian or even within India itself. We can talk to Karnataka people or Andhra people or Kerala people. We are able to understand. However, they speak. Even the accent varies also. Will be able to understand and we are able to respond. And my system also should be able to do that. So these are the skills required for the computer to act like a human. Learning, reasoning, solving problem and language understanding. So that is what is the goal of artificial intelligence. Okay, it should exactly act like a human. So why computer has to do all these tasks? Why not man? When a human is there, why are we expecting all these things from the computer? Can anybody give me answer? Computer is trained one. We are the creator. We are the one who is going to induce or influence our knowledge to the computer. So the most of the time consuming task is done by the computer. We will be able to do something so productively. Right? As we are the creators, we can concentrate on various tasks so that the computer will take care of the time consuming. Not only that, the places where human will be under risk, like maybe coal mining, underwater process, there and all it will be. We are hearing lot of incidents where the human is involved over there under the drainage and all those things. If your robot is able to do, powered by artificial intelligence, so such a risk can be avoided. Human life can be saved. Okay, not only the purpose, that is also a purpose why we are going forward. Types of AI. So there are various types. See, as imagine you are going to design an AI model. When you are planning to design an AI model, you must know various basic concepts about artificial intelligence, and that is the reason these are the inputs given to you. Types of artificial intelligence. It is mainly classified as three major types. Narrow AI, it is otherwise called as weak AI. What it does, it will be able to perform only a dedicated task. Okay, when you say your Alexa virtual assistant, it will be able to only listen your command and respond accordingly. Respond in a sense only by voice, not anything else. If you go with your chat GPT, only textual conversation. You can ask something, it will reply you via text. If you ask your chat GPT to sing a song for you, it will not be able to do. Okay, but that is also possible with now our co-pilot. It will be able, it won't sing, but it will give you a song. If you just give some constraint, it will be able to compose one song and give you. So because every day the research and progress is going on artificial intelligence. So what you need to understand here is, it is dedicated to assist with take over a specific task. If it is an autonomous task, it will be able to only drive the car, it will take the direction, it will decide only for the driving purpose. It will not be able to do any other task. If I ask my car to play some song, it will not be able to, because that is purely designed for a particular task alone. Now, in the current scenario, whatever the AI is existing, everything comes under narrow AI only, because general AI is little ahead of that. What general AI does, it should exactly like our human. You can correlate with It&Iii movie. Okay, so in It&Iii movie, if you just remember the Chiki Robo, it will just read that MBBS book and it will be able to scan and it will explain to that girl and all that. Okay, so like a human, it reads and helps. And when rowdies are coming and troubling, this is going and fighting with them. So that is all done by like a human only. So that robot's job is not only one job, it is able to do multitude tasks, right? It is not doing only one thing, it is doing all the works. So that is what is the imagination or expectation from the artificial intelligence, but we have gone to only one dot, not even a 10% or 20%. That is a huge task. Research is still going on. Okay. Next is super AI, that is extraordinarily intelligent machine, where it must even have an emotion. It must be able to cry, or if you are crying, it will be like a friend, it will console you, or it will get angry and beat you and all those things. Okay, so what the human is having? Lot of emotions. With all emotions, if the machine is going to be, that is called as super AI. We have not even touched the general AI, only then we can move on to super AI. I hope you have understood the difference between all the three of them. Narrow AI or big AI, that will be performing only a dedicated task. Beyond that, it cannot do anything. Okay, whatever the AI you are taking, Google Map, it will be able to give you the direction. If you ask you to give the cost, what will be the cost between this place to that place, it will not be able to say. Okay, and Google Map or your Ola, Uber, everywhere AI we are using. Okay, so there if you consider, combination of two things are used over there. But however it may be, narrow AI is used to perform only a dedicated task. Beyond that, there is a limitation for its job. Whereas general AI, it will be able to think. See, recommendation and all comes under thinking part, but we are not able to combine multiple tasks over there. My recommender system will be able to only recommend, not beyond that. Okay, so when we are able to combine multiple tasks together and make it as a single system, then we can say that to certain amount we have achieved of general AI, but still we are very far from super AI. Here are some of the examples for you. Your Google search, virtual assistant, email spam filter, you are receiving mails. In that part of the mails go to spam, because it analyzes, it is not from the authorized person, or it is not from the regular sender or recipient, it goes to the spam. It is filtering according to from where all the content and all those things. Manufacturing and drone robots where AI is used, that will be doing only that task alone. So all those things are the example for narrow AI. And the next thing is robot, just we have given because it should be like a human. How human is able to see, I am able to educate you, I am able to cook, I am able to play with my kid, like when I am able to do multiple tasks. Okay, being a human. Same way, if my robot is able to do, I can say that comes under general AI. Fine. Various approaches of artificial intelligence. Now we have only learned various types of it. How are we going to approach artificial? Like when you are planning to design AI, what are all the things should be there in your mind? There are majorly 4 approaches. Let me start from acting humanly. So this acting humanly, it will just act like a human. Okay, your computer acts like a human. What is it called? The Turing test. There was a mathematical expert, mathematician who introduced the method called Turing test. Okay, so he was the one who made an abstract machine for all the computers before the invention of the computers itself. He was not knowing how the computer is going to be, but he was having a dream that when the computer is introduced, it will be able to do all these things. Okay, for everything he had made an abstract machine. So that is a very big subject. Let us not talk about it. So what is Turing test with respect to artificial intelligence? Imagine there is an interrogator or there is a judge over there. Okay, so he is monitoring the communication between 2 parties. One is a human, other one is a computer. Okay, please follow me. One is a human, other one is a computer. They both are conversing. At the end of the day, after some 5 or 6 steps of conversation, if this judge or the interrogator is able to differentiated. That is the thing. So after all the methods, we will see one game over there so that you can understand. The other three approaches are related to that thinking humanly. So where our nervous system process will be analyzed, understood, because how you think, how each person is thinking. So that comes from our brain only. When the nervous system, when our brain how it is processing, if we are able to analyze the process, that could be induced to the computer so that my computer can think like a human. And psychological thing, when I will smile, when I will get angry, when I will laugh, when I will feel hungry, those things and all, if I am able to understand, I will be able to give a thinking part to my machine. Okay, my psychological process and my thinking process, everything needs to be analyzed, and I need to make a cognitive model to make my system to think like a human. Okay, so these are all the approaches when you design an AI. For what purpose we are designing a AI model? Based on that, which approach we need to choose need to be decided. Clear this? Now it's okay. Next, acting rationally. It is almost related to this only. Acting humanly, make a mistake. May be a mistake. Okay. It may act, but sometimes it may. I have made it as a artificial machine only, but the judge is able to identify that is the machine. So my machine failed the test. Correct? My machine failed the test. I have to see that my machine never failed the test, so that the success rate will be improved. Such approach we call it as a acting rationally. Rational abinale less error. Error should not be there. Next is thinking rationally. Laws of thought approach. Like when I say A is equal to B, B is equal to C. What do you say? What do you say from this? A is equal to C. Correct? I am establishing a logical relationship between two equations. A is equal to B, B is equal to C, then automatically I will be able to say A is equal to C. Because I am a human, I am able to say the same kind of logical relations, inference relations, and all those things need to be given to the computer to think rationally. So these are the four approaches. Just pause. AI algorithm. So we have AI algorithm. It will work for certain kind of input, not for all sort of input. Okay, and if it is dynamic, it is fine. As and when the data is getting changed, it will be able to change it yourself. Otherwise, it will be a problem. So AI algorithm is biased, black box problem. Again, you set certain task for a particular machine. AI model, you are making it, okay, and you are certain a particular task for that. Suppose you want to scale it, you want to upgrade it, that is not possible with the hardware based AI models. If it is a software AI model, currently it is possible. Whereas hardware, it is not possible. You have purchased Alexa, okay, and there must be some add-ons for the Alexa. You cannot buy and attach over there. You need to go for another device only. Whereas it is a software-based AI model, now the scalability is achieved. Okay. So then we have requirement of high computing power. With all computers, we will not be able to get the benefit of artificial intelligence. So whenever your AI or you are expecting your computer to be like a human to do more very important intensive tasks, we need to go with a supercomputer. With the existing computers, everything is not possible. Only to certain amount of benefits only we are able to achieve. It requires or it needs more computing power. Complicated AI integration. So integration is complicated because see, we are not talking about the first part, narrow AI. Even in the autonomous car also, the process of it started long before. Now only we could succeed it because they were facing lot of issues in that, and finally the integration. So in that we have succeeded, but when you consider on all the domains, on all the AI models, still it is a challenging task only because we want our computer to perform multitude tasks. It has to do multiple tasks. So when that is the case, you must integrate it properly. Only then there must be a coordination. When you say robo has to do all the tasks. That is your imagination or expectation from the robo means the integration, the coordination must happen properly. That is the challenge still now. Lack of understanding of implementation strategies. So still R&D is going on from all the people from the implementation side. Still we face some problems and legal concerns. So we make one AI model that has been utilized by the government. Okay, so it may be a drone or something like that. So in that AI, it is powered by AI. So what will happen? It just train every bill. So it is able to observe all the incidents what is happening over there. But the intention of that is different. But in addition, it collects so other informations too. So which may be a problem for our freedom. Okay, so though it wanted to collect one kind of information, it gives additional because it just collects all the information in that environment. That may be a problem for us. And whenever we design AI model, we need to even see the consequences of it. So that is a barrier in the AI design. Yeah, very important thing. Technically, we are going from now onwards. Agents of artificial intelligence. So when I am able to do certain tasks, I say I am the agent. I am the agent. I am able to teach you. I am able to do any other task. So I am the agent. Similarly, when my AI or when my computer, when my system is going to be an artificial machine, it is going to get the artificial intelligence. We call that machine as an agent. Okay. So the Alexa or your autonomous car or your Google Map, it may be your social media, whatever it may be, the agent must be there to perform a particular task. Okay, so agent is like the person who will be performing a task. How he will be performing a task? Using person, action and factors. So we use lot of sensors which will be collecting the information. Again, I always go with this virtual assistant as an example. I give an instruction to my Alexa, play a song of S.P. Balasubramanian. This is the instruction I am giving. My oral instruction is being taken as an input by the sensor. Okay, taking the data from me. I am in the environment. Okay, it takes the input through the sensor, it processes it, and then it provides the action. So the effect task is like here you see a kind of picture. Imagine that is a robo. Okay, if it is a robo, your robo, let us assume vacuum cleaner. Vacuum cleaner powered by AI. So you just deploy that thing in your room. So it will be moving around the left, the right. With that move, it will move. And if it finds a dirt over there, it will suck that dirt. It will suck. So how it is sucking? So there will be some other arms kind of thing that will take off the dirt over there. Suppose you are designing a robo to go and bring some particular thing. You are instructing your robo go and get my mobile phone. This is your instruction. So your robo, how it will actuate it, how it will implement it by action. It will walk towards the mobile. It will pick the mobile by hand, and again it will walk by leg and give it to me. So how it is executing that? By hand and leg. By arms it is doing all those things. So how a particular task is executed, that is by factors. And what kind of action is performed, that we say it is an actuator or it is an action function. So through sensor it collects the data from the environment, and to affect the environment it performs some action. And to do the action it uses some of its part of the AI model. That we say it is a effectors or actuators. Is it clear? Sensor, percept, action or actuator, effector. It's clear? It's clear, right? So it takes the input from the environment. Imagine it is a self-driving car, autonomous car. Okay? When the car is moving, it is seeing the vehicle very close by. Okay? So the distance is very, very short. So it has to apply a brake. So it sends the distance or it sends the traffic signal through sensor. Okay? Then it has to apply a brake. To apply the brake, you have a system to apply brake, or you want to control the speed. So you use the accelerator or gears, using which you are doing all these things. Okay? Those things are called actuators or effectors. The one which creates effect on the environment, we call it as actuator. The action what you are performing, that is applying brake, is the action. Taking data from the environment, that is there is a red signal in the traffic system, is a percept which is being observed or collected by sensor. So this is what is about agents in AI. Is clear? Shall we proceed? Yes? I don't see any smile over there. Agents, whatever I explained only you can see over here. The major components would be sensor, actuator and effectors. Next. Yeah. So here is one example, as I mentioned, vacuum cleaner. Next. Yeah. See here. You have a vacuum cleaner over there. This is a house where there are two rooms are there. On both the rooms you can see some dirt. Okay. So yeah. So the agent or robo is the vacuum cleaner. Okay. It's not the dirt. Dirt is the environment. Vacuum cleaner is the agent. So this agent will take the input as location and the content. Where is the location? Where is the location it has to move, and what is there? If there is a dirt, it has to suck. If there is no dirt, it doesn't have to do anything. So there are two rooms here. When it is in A, if it finds there is no dirt over there, it has to go and check the other room. There also there is no dirt, it can just be idle like us, like you. Okay, when there is no work, it can just sit like you. If there is a work, it can react. So I want your reaction now. Okay, not like this. Yeah. So percept is location and content according to this agent, and the actions could be, if it is in room A, it may move towards the right. If it is in room B, it may move towards left. Those two directions it will move, and then if there is a dirt, it will suck the dirt. When there is no dirt, it won't do any operation. No operations. Clear this? So these are the important terminologies in AI. Percept sequence means collection of input. We say percept sequence. Agent function. What the function my agent is doing? Maybe moving right, left, up, or no operation. Agent program collect all the agent action is called agent program. Next, next. Any AI model. When you are designing AI model, few things should be there in our mind. Okay. So performance measure. Whenever you make something, what it is going to give? What is the goal of my particular model? If it is a smartphone, what I am expecting from my smartphone? If it is a smart home, what is my expectation? What is the objective of that particular thing? Right? Smart home now what? Everything is controlled by some remote. Correct? So I don't have to tell anything. Or the moment I go near the door, it should open. There must be a sensor. It will sense me going to cross the door, so it should open. Or by sitting in one place itself, I should open a particular room. I should close the particular room. I should do all the operations in my house by sitting in one place itself. So that we call it as smart home. Your smart TV, your smartphone, everything is AI powered only. Okay, whenever I design something, there must be some objective. So of course, performance measure. So performance measure now how my particular model needs to perform. You are designing something with some goal and objective, but it is performing something else. This is a failure model, right? It is a failure model. So your friends only have designed a robot to take care of a babysitter. It has to act like a babysitter, which means whenever the baby moves out of the bed, immediately it has to go and protect the baby, just turning to the other side. That is the expectation from that robot. Rather than doing so, it is moving away from that place. Now, it is not working what I expected. What is the performance I expected from my robot is that the moment the baby is turning towards, going to fall down, it has to go and protect. It has to stand near the baby itself. Whenever the baby is crying, it has to inform to the mother that the baby is crying and not able to control. This is what the expectation from my robot. But rather than doing all these things, simply it is doing some other thing, moving here, there, opening door, closing door. No, it's failed. Okay, it is not doing the task what I am expecting from that. So when you are deciding something, I have to set up certain objective performance measure. So here with respect to vacuum cleaner agent, amount of dirt cleaned up. Many times you say your vacuum cleaner is not cleaning the room. Half the dust is there itself. It is not removing completely, which means it is not working fine. Whatever the performance I am expecting from that is not happening. Amount of time taken, as it is running on electricity, but it is taking too long to clean one particular thing, again I am losing somewhere, right? The performance, what I expect, within a short amount of time it has to clean. Amount of electricity consumed, again if it is consuming too much electricity, I cannot afford that, okay? Then level of noise generated. You have babies or older people, they is creating too much noise like this drilling machine and all, again it will be a problem. So here for the vacuum cleaner, what I am setting it as a performance measure, amount of dirt cleaned and how long it is taking, amount of electricity consumed and the noise what is making. Similarly, for the self-driving car and for any agent, what I am trying to say here is, for any agent, you set up a performance measure. This is what my mission, this is what my agent is supposed to do. This is what my expectation from my agent. With that only we should go designing the agent. So, rational agent means with the less error, with the more success rate, it has to be. So, types of environment, this is another important thing. So, where you are deploying your agent, that matters, because in that surrounding only it will be able to collect the data. Okay, my Alexa is in my room. Okay, if somebody is giving an instruction from here in college, I will not be able to respond. Okay, that agent will be having a certain environment where only it will be able to work. Clear this? So environment is something like the location where my agent is going to play its role. There are various types of environment. So though I have listed many, only few are very, very important here. Fully observable and partially observable environment. I can give you an example for fully observable environment. Chessboard. chessboard. If it is an online chess, okay, the agent or AI or the computer will be able to see all the moves of the user. Do you agree this? Whatever I am user and my computer is the AI. Okay, so whatever the move I am taking, my computer will be able to see the complete chessboard. That is called fully observable environment. When I am keeping a CCTV over here, the complete classroom can be observed, but the direction is towards this. It will not be able to observe the data from outside or outside the classroom. So when my agent is able to collect the data fully of the location, we say it is fully observable environment. Better example, chess game. The second thing, partially observable. Imagine card game. Cards, you are playing in cards, okay? So two persons, or it is an online card, poker game. So I will be keeping some card which will be towards my class. I consider a poker game where computer will not be able to see the cards towards you, because how do we keep the card towards us? Correct? Have you ever played cards? Played or not? Or have you seen the people playing the cards? So cards, what we keep, it will be towards us only. Opponent will not be able to see. Here my opponent is my agent, AI agent. It will not be able to see completely, only it will be able to see its own part alone, which we call it as partially observable. Partially observable. Same example, CCTV I can say. If someone is coming and asking, in the corridor something had happened, did you notice it? Let us check the CCTV footage, it will not show. Because it will be able to observe only within the classroom, not the outside the classroom. Get my point? So partially observable means only partly the environment will be visible to the agent, not completely. Deterministic means from the current state, when I apply one particular input, it will definitely move on to next only. When you consider your vacuum cleaner, when it is in room A, when it finds dirty on room, it definitely will move towards right only. Okay? When it is in A, and when you apply the input as dirt on B, it will move towards B. So from the current state, for a particular input, it will definitely move on to this particular state only. Like that, if I am able to determine, it is called deterministic environment. Okay, it can go only to this room, not anywhere else. That is about deterministic. Exactly opposite stochastic. Stochastic means I will not be able to determine. It may be a problem, may or may not go. Right? It may or may not go. So you are using your self-driving car. You are expecting that car is going to take towards right. Okay, but if it goes towards straight, that is undetermined. That is probability. Depending upon the traffic, initially when it started, the route may be different. As it travels, the route may be changed. That is stochastic. Okay, deterministic now it is determined. Stochastic now it is not determined. This will be continuous. So it will work on a discrete. Here and there the data will be there. With that it will be working continuous. Sequentially it will be working. Like you are some customer care AI and all will be conversing with you about the product when it is talking. What was your previous question? Based on that, the continuity will go on. Suddenly it will not change a direction. That is about sequential. So discrete means it will be totally different here and there. Like the tic-toc-toe, one game is there, right? So then lines and all will be putting on. So opponent may put the line over here, but you can put the line somewhere else. There need not be any continuity. In such environment we call it as discrete. Then we have single agent and multi-agent. So there will be only one agent performing the task, which we call it as a single agent environment. We can say the vacuum cleaner itself, or the game where even chess game or poker game, single agent. Multi-agent means like your football game. Okay, there will be multiple people. Depending upon the anybody can play in that. Accordingly, you have to respond. So you don't break your head for all these things. These are all the things you must just know. Various environments are there. When we are designing anything, when we talk about the environment, these 4 P's must be there in your mind. P's, P-E-A-S, performance measure. environment, actuator and sensor. With all the four only we will be able to create a agent, or we will be able to create a AI model. Okay. Next. Yeah, see, this is another thing, table lookup driven agent. So how the vacuum cleaner is performing, or how any agent is performing, can be recorded in the form of a table where you set up all the expected states. That will be, I will show you in the next slide. So with various states you make a table. Based on that only the process or the implementation could be taken place. When you are designing, these are all the steps it may take, and the steps to be implemented through any of your programming languages. See here, look at the thing. So these are the 8 stages with respect to your vacuum cleaner. Okay. So vacuum cleaner task is very simple. You have 2 rooms over there, and your vacuum cleaner can be initial state. Can be kept either on this room or on that room. 2 possibilities. Okay. Initial state. Both the rooms are dirty, and my vacuum cleaner is kept either on A or on B. Second possibility would be room A is having dirty and the vacuum cleaner is kept there itself. Okay. So next state would be room A is dirt but vacuum cleaner is kept on room B. These are all the possible states. With the possible states only we will be establishing a move. If this is the state, what is the input I should give? If this is the state, what is the next step it has to move on? Okay. So next would be vacuum cleaner is kept on room A but the dirt is over there. The other state would be vacuum cleaner and dirt are on room B, the other room is clean. So it has to do only suck operation. So based on these states only, I will instruct my vacuum cleaner to do a particular task. Okay. So first I will set up all these things for the environment. Finally, both the rooms are clean and vacuum cleaner can detect either on A or on B. This is the goal state, because the expectation or objective of my vacuum cleaner is to clean both the rooms, as there are only 2 rooms. When it is clean, when both are clean, I will stop the process. So to perform this, I will be having 8 states. But for the other agents, there will be lot number of states. First, you need to set up the states for the environment. Only then we will be able to implement it. Next. Yeah, the same thing is given in the table form. Percept sequence. The entire thing is called as a percept sequence. Individual thing is called a percept. Okay, we saw some terminologies with respect to this. So when room A is clean, we need to check for room B. Correct? A is clean now. We will be checking how about room B. So move towards the right. When A is dirty, you need to say your vacuum cleaner to suck the dirt. Operation is done. When B is clean, move towards left. When B is same, please remember it is not in the sequence. These are all the possible states only. You can be in any state. Based on that only you can implement it. Don't think that A is dirty, A is the dirty is removed. Here itself we have moved right, then why we did not clean. That thing and all you should not say. All possible states they are setting up, and then we go for the implementation. Okay. So this is the corresponding Python implementation for the same very simple coding where we have not applied any the technical algorithmic techniques and all. You just see straight away I will go here. So these things and all you can understand. You can be iterative manner. I am going to execute this for only 5 steps. Okay. So per day I will operate it for 5 times. I will not do it for 24/7. Right. So some periodically if I do, that's enough. So I am going to do that. I am going to operate my vacuum cleaner for 5 times. So self position is 1. But you know it is dirty. If it is dirty, I am assigning 1 to that. If it is clean, I am assigning 0 to that. So what should be the final value? When the value is 0 for all the states, we can say that the room is clean. Correct? When it is clean, 0. When it is 1 only, I will say that suck the dirt. When it is 0, no operation. Doesn't have to do anything. Self position like from 1 to other, we kept on moving. Okay. So final state of environment is environment is equal to 1, 0, 1, 1, 0. What do you understand from this? So first is dirt. Next, it is clean, so it doesn't have to do any operation. Next, 1, so it is having a dirt. Next, again, it is dirt, 0, 1. So in that way, so you call the function. So the clean position, first 1 is there, 1 was there, and previous one. Yeah, 1, dirt. So the first it has to suck the thing. So it is cleaning that. Second, it doesn't have to do, so that it moves on to 0, 1, 2, 3, 4, 5. So it will clean and previous one. So it needs to clean 0, 2, 3 and 5. Am I right? Because they only find dirt over there. That is when it is moving. Here I am not specifying room A or B. I am saying when you are in this position, when you take towards this way, you need to clean. Like only move alone I have done here, because when I mention A, B and all, I need to use my searching algorithms, DFS or DFS, which will be explained later. Next one. Same, accordingly generating and the final state of environment, all are having 0, which means all the rooms are clean. Clear? Next. One more very important thing you need to know, types of agents. Agent we discussed, rational agent also we discussed. There are various types of agents. Again, depending upon the requirement, need, you have to choose a particular agent. Okay? In the existing AI models, again, they have used only few agents. The first one is simple reflex agents. Simple reflex agents, here, it will only act according to the current situation. It doesn't worry about the consequences of it. For example, without knowing the chess game you are playing, you won't be knowing to move your coin. Just like that you move. Okay, you may not be knowing the opponent may cut you. Okay, or the game itself may stop. Without knowing it, just at that particular scenario, in that environment, whatever the input you are receiving, accordingly you proceed without knowing the past history as well as the future consequences. We choose simple reflex agents. When you are asking your Alexa to sing a song, it doesn't worry about the future and all. It will immediately sing a song for you. When you ask it to give a time, it will say immediately the time. So whatever the input it receives at that point, it is responding accordingly, which we call it as simple reflex agent. So here, this is the structure for that. It takes the input. Input is called as process here from the environment to the sensor. What the world is like now, which means what the world is expecting me to do now. So whatever the input they are giving me, I have to respond for it. That's it. So it acts according to condition, action, rules. I would have told when the question comes like this, you have to reply so. When you see a red light on the traffic, you have to apply brake. This is the condition I have given for this particular condition. This is the action you have to perform. I have set up already a rule accordingly functions. So what action I should do now? Through actuators, it performs the action on the environment. It's clear? So it doesn't check anything else. Only the current input. And what is the rule? What is the condition is told to me? As simple as that. Okay? Next. The second is model-based reflex agent. This is almost like a simple reflex only, but there will be a model setup. Like this is how I should go. Okay. See, if your parents have given you permission to do some course, just like that, some C, C++ or Pascal, Fortran. If you do, it is of no use. What the world is expecting? What is the current scenario? So I should do course on AI, Aiml or IoT or something like that. Okay. So what is the current scenario? Accordingly I will go, but still I will go along with the condition. Okay. Little relaxation is there from that. That is about model-based reflex. Next. Goal-based agent. I will set up a goal like here. Vacuum cleaner. What is the goal of vacuum cleaner? What was the goal of vacuum cleaner? To clean the room. So till both the rooms are clean, it will be operated. It will be operated. So till you achieve the goal, the function will be taken place. So here there is no certain condition at all. And I only check what dirt is there or not. When there is a dirt, circuit. When there is no dirt, stop the operation. So till both the rooms are clean, it will be operated. There is an input from the environment about room A or B, dirt, something something like that. What the word is right now, you decide that these are all the things I will be saying. What is the current state? How the world evolves? What my action do? What is the current state now? It is I am in room A and I am receiving input as dirt. Okay, so if that is the case, I need to clean it to achieve the goal. Next, utility based also similar to your goal based only. It is like you are traveling from Trichy to Chennai. There may be so many routes for that. Okay, so which route is shortest? I am having only 6 or 7 hours of time. Within that, I have to reach my home and then I have to go to the college. Okay, so then I will choose the shortest path and then move. Suppose I am traveling during daytime, where while traveling I need to find some hotels, I need to refresh myself and all. Then accordingly I will choose the path. My utility is that I should be happy, I should I should feel good when I go via that route. Accordingly, if I am choosing a particular path, for that the agent what is used as utility based agent. Same thing you can find only based on some utility. What is the utility here? I should reach within this time. That is the purpose. Or I should have lot of restaurants on the way. That is my utility. So based on the utility, the task is done by utility based agent. Next, learning agent. So it learns from the behavior of the customer. Amazon or any online shopping, if you take, it observes what you are purchasing. Okay, so based on that, it